Hello, good day viewers. In today's lesson, I'm going to be revealing a lot of secrets on how to find the nth term of a sequence with no common difference. But before I start with that, I want you guys to please, if you haven't subscribed to this channel, please kindly do so as to get notified about my next videos. This is a common question in most exams, especially JAMB, NECO, WAEC, GCE, or any exam you can think of. Now let's get started with this. The question says that what is the nth term of the sequence 2, 6, 12, 20? Like I said, this is without no common difference. Now, looking at the sequence given to us, we have 2, 6, 12, 20. Right? You observe that there is no common difference in between them. That is, the difference between this and this is simply 4. Difference between this and this is simply 6. And here to this is simply what? 8. That is when you subtract. Okay? Now, you must make sure that you get the same constant term before you stop. Now, if I continue by subtracting this from this, I'll have 2. The same thing here, I'll have 2. So I have the same term. So how many steps did I move? I moved twice. So that means I'm moving the first time and I'm moving the second time. Okay? The steps involved here is simply a quadratic expression. That is why I'm going to be applying a quadratic expression to solve this question, because I moved twice here. Okay, so a quadratic expression, an squared plus bn plus c. You may be wondering that why am I using n not x? In quadratic expression, what we are familiar with is simply x, but because we are actually looking for the nth term of that sequence, so it's best you use what? N. So it's still the same, just by changing the x to n. Okay, so from this now, we need to calculate the value of a, b, and c. A, b, and c, that's our major target. Now, what we do is this. Since these two falls are the first term, so we say when n is equals to 1, that is, we are getting the value for these two. So we said when n equals to 1, if we replace n equals to 1 here, we are going to have the expression to become a plus b plus c. Then is equals to the term we have here, which is 2. We can call that equation 1. Are we following? The first term, so we say when n equals to 1, we replace n equals to 1 here. We are going to have this expression, but it will be equals to what? The value we have for the first term here, which is what? 2. Now also, when n is equals to 2, if I replace here, I'm going to have 4a plus 2b plus c. I hope that is clear. 2 raised to the power 2 is 4. So 4 times a is 4a plus 2b equals to plus c. Then it will now be equals to what? This 6 over here. So which is 6, because that falls at the second term. Okay, same thing. This is equation 2. Now, when n is equals to 3, if I replace in that same expression, I'm going to have 9a plus 3b plus c. Then it's now going to be equal to the third term over here, which is what? 12. Equation 3. I'll stop there. Okay, now, what I will do next is that I'm going to find a way of reducing these 3 equations to just 2 equations. So I'm going to solve it simultaneously, right? So if I say subtract equation 1 from equation 2. Of course, equation 2 says that, sorry for that, let me get another marker here. Equation 2 says that 4a plus 2b plus c, right? This is equation 2. Then minus, we are subtracting from equation 1, that's a plus b plus c. Then it will be equals to 6 minus 2. Is that not it? So we have 4a plus 2b plus c minus a minus b minus c is equals to what? 4. So of course, if you collect like times, 4a minus a will give 3a, plus 2b minus b will give b, then c minus c is 0. Then everything is equals to what? 4. Equation, let me call this equation 4. Are we following? Okay. Now the same thing, I've reduced these 2 to just single. So I will say subtract equation 2 from equation what? 3. So say subtract equation 2 from equation 3. So of course we are going to have, by subtracting, let me manage this space, so I'll just reduce the particular value I have. I'll reduce this. So equation 3 says 9a plus 3b plus c minus equation 2, which is 4a plus 2b plus c is equals to 12 minus 6. Right? So we end up having 9a plus 3b plus c minus 4a minus 2b minus c is equals to what? 6. We are still on that equation, okay? So if you subtract 9a minus 4a by collecting like times, I'm going to have 5a. Then 3b minus 2b, I'm going to have plus b. Then c minus c is 0. Then everything is equals to what? 6. Equation 5. So I'll now combine, since I have equation 4 and equation 5 to be reduced, so I'll now combine equation 4 and 5. So if my equation 4 says 3a plus b is equals to what? 4. Then also 5a plus, this is equation 4, b equals to 6. This is equation 5. So what am I going to do here? I'm going to subtract, because I'm going to apply what we refer to our elimination method in simultaneous linear equation. That is why I need to stay on this channel, so as to get more of it on my next videos by subscribing to this channel. And let's proceed. If we subtract this simply means 3a minus 5a will give minus 2a. b minus b, 0. Then is equals to 4 minus 6, also minus 2. Right? So minus, we eliminate minus, divide what's by 2. So therefore a is equals to what? 1. So we have gotten a to be 1. So we can now get the value of what? B, by replacing in any of the two equations, maybe equation 4 or equation 5. Okay, say replace a equals to 1 in equation, let's use equation 4. So equation 4 says that 3a plus b is equals to 4. So when a equals to 1, of course I'm going to have 3 into bracket 1 plus b equals to 4. So of course b will be equals to 4 minus 3, and b equals to what? 1. So since I've gotten the value of both a and b, what am I going to do next? I'm just going to what? To replace. Look at that, means since my a is 1 and my b is also 1, so I can easily replace back in equation 1 to get my what? To get my c. Right? So I'll just say replace b equals to 1, a equals to 1 in equation 1. And equation 1 says that what? Let me manage this space. Let me use this space. Let me go this part. So equation 1 says a plus b plus c is equals to what? 2, right? So when b is equals to 1 and c is also equals to 1, so I will have a plus, when a equals to 1, which is 1 plus, then b is also equals to what? 1 plus c is equals to what? 2, right? So I'm going to have c equals to 2 minus 2, because 1 plus 1 will give me 2, right? So we have c equals to what? 0. So if c equals 0, if I replace the three values, since, let me put it out there, a equals to 1, b equals to 1, c equals to 0. So if I place these three values into this particular what? Expression here, so I'm going to have my expression to become, establish an squared plus bn plus c. So when a is equals to 1, I'm going to have n squared here, plus when b equals to 1 plus n, then plus 0. So everything give me n squared plus what? N, which is my expression, which that is option C, which is the nth term of that word sequence. So how are you sure maybe this particular answer here is correct? Okay, this is what you do. If you take this is the first term, right? Are you sure maybe this answer is correct? This is the first term. When n equals to 1, 1 squared plus 1 must give back this particular answer. Now to get 6, when n equals to 2, 2 raised to power 2 is 4. 4 plus 2 is 6. Right? You can see it's correct. You can see. Okay. So when n is equals to 3, 3 raised to power 2 is 9. 9 plus 3 will give 12. So that means this particular nth term of the sequence is what is correct. So this is what I have for you guys today. Please kindly like this video, share this video, and subscribe to my YouTube channel, because that's the only guarantee of remaining to this channel to get notified about my next videos I will see you guys in my next class. Stay tuned. Bye for now.